.gr, India has .in, and then comes the Russian Federation has .ru, and then comes the United Kingdom. Then the domain name system is chiefly used to translate a hostname into the numeric IP address, and DNS is an example of distributed database, and if that server can resolve the hostname, it does so. If not, that server asks another domain name to server. Here you see the devices and the layers at which they operate. In the OSI model, we have 7 layers, out of which 7 layers, the first 3 layers are the physical layer, data link layer, and the network layer. In the physical layer, we have the physical connectivity, that is all the database or hardware that are residing on the network comes under the physical layer, like hubs, switches, hubs, etc. Like how many volts are there, how many volts are there, how many current is being passed, what type of cables are being used, etc, etc. That at the data link layer we have the concept of the packets, and packets are being have to be transferred over the network. Then we have on the data link layer we have the hardware like switches, bridges, and the NIC card, that is network interface cards. And at the network layer where actually the data is being transferred on a particular route, then the routers and the layer 3 switches will be used for the sending the data. Then comes the NIC, that is network interface card. We all heard about this network interface card. Yes, this card is required to connect to the internet. We cannot connect to the internet if we do not have this NIC card. This NIC has interfaces for the twisted pair, thicknet, and the thinnet connectors. Then comes the repeaters. A signal attenuation or signal loss, the signal degrades over distance, because in the LAN, as we have the large area to cover, and at some point on the wire, the signal degrades. The weakness of the strength of the signal become loose, and the signal degrades over distance. Then we need the repeaters. The repeaters clean, amplify, and resend signal that are weakened by the long cable length, and it is built into hubs and switches. Hubs in today's D-Link types, etc. in the hubs and switches, these repeaters are the built-in. Now here you see the working of in detail the working of the hubs, which are working on a layer 1 of the OSI model. Hubs regenerate and retime network signal. Hubs propagate signal through the network. They cannot filter network traffic. They cannot determine the best path. They are used as network concentration point. They are really a multi-port repeaters, and uplink port crossover mode or strain through the mode. So these hubs are used to connect many of the PCs over the network according to the ports, and these hubs also helps to regenerate and retime the network signals. Then comes the bridge. Bridge, as I have discussed earlier, is used to connect two LAN, two areas, two local area networks, or any two networks we have to connect it through the bridges, and a layer 2 device, and it is operated on the data link layer. The layer 2 device designed to create two or more LAN segments, each of which is a separate collision domain. The purpose is to filter traffic on a LAN to keep local traffic local, yet allow connectivity to other segments of the network. filter traffic by looking at the MAC addresses and the frame filtering. So this bridge is uh, designed to create two or more LAN segments, and they are which are separate which are at the geographically two different stations. And if the frame is addressed to a MAC address on the local side of the bridge, it is not forwarded to other segments, and MAC addresses on the other segments are forwarded. Bridge maintain a MAC address table for both segments they are connected to. Here you see the cycle of bridge. Bridge network can span many of the segments, and broadcast can send to all the segment. Here you see segment A, segment B. These are connected by the bridge 1. This is segment B and segment D. These are connected by the bridge B2. These are the segment D and segment H. These are connected by the bridge B7. Here you see likewise these two are connected through B8. So these bridges can help to connect two segments to different type of networks, and the broadcast are sent to all the segments. And in continuation with the bridges, we have the concept of distributed spanning trees. If all the bridges forwarded broadcast, infinite loops can occur, and the bridges perform DST on both to determine which of the packet will not be forwarded or broadcast. The next of the network device is the switch network. Here we have the shared Ethernet network perform best when kept in 30 to 40% full capacity. This is the result of the CSMA CD, that is and the LAN switch is the high speed multiport bridge which segments each port into its own collision domain and can access the full bandwidth. So this CSMA series helps to determine the collision detection. Where is the network collision? It helps to detect that. Here you see the devices and the layers at which they operate. Here you see it is the routers, layer 3 switch. These are work upon the network layer, which is the third layer of the OSI model, and switches, bridges, NIC card. These are the connecting devices which work on the second layer, that is the data link layer, and then comes the hubs which works on the first layer of the OSI model. Here you see each in the switches, each port is simulated segment to the LAN. Here you see there are various ports, and computers are connected to the various ports over the switches. Switch, the most important property of the switch is store and forward. It helps to do error checking on each frame after the entire frame has arrived into the switch. If the error checking algorithm determines there is no error, the switch look in its MAC address table for the port to which the forward the destination device. It is highly reliable because does not forward bad frames, and slower than other types of switches because it hold on to each frame until it is completely received to check for error before forwarding. So today's switches are not the passive switches or the dumb switches. These are the active switches which are doing their own more options, like error checking is there, like highly reliable. They do not send any bad data because they check the data, and they remove the bad sector frames from the data also. And the another property is cut through switch. Cut through switch is faster than store and forward because that does not perform error checking on frames and reads addresses information for each frame as the frames enter the switch. After looking up the port of the destination device, frame is forwarded, and the forward bad frames, if they forward bad frames, performance penalty because bad frames cannot be used and replacement frames must be sent, which creates additional traffic over the network. The next type of switch is fragment free cut through switch. This fragment free cut through switch is combined speed of the cut through switch with error checking functionality. It forwards all frames initially, but determines that if a particular port is receiving too many bad frames, it reconfigures the port to store and forward made, and it is preferred switching solution. So these are the three different types of switches we have learned. Then comes the unmanaged or intelligent switches. Unmanaged means providing LAN with all the benefits of switching, and it is fine in small networks only. Intelligent switches track and report LAN performance statistics, means keeping track or log of the data, that who is sending the data, who is receiving the data, who is accessing the data, who is accessing the which part of data, etc. And have the database ASIC application specific integrated circuit on a board to collect and store data which you view through a software interface. Then come the layer 3 switch. By defining a switch filter or forward frame based on the MAC addresses, this make a switch a layer 2 device. Now we have layer 3 switches which have routing capability. If a data frame cannot be switched, it can be routed. Each port is a separate LAN port, but the forwarding engine actually calculate and store routes based on the IP addresses but not on the MAC addresses. So usually support only IP or IP and IPX type of protocols. The next type of switch is the VLAN switch. VLAN switch is the virtual local area network. In this virtual local area network type switch, each port on a switch defines a collision domain, and the entire switch form a single broadcast domain. The virtual local area network can define multiple broadcast domain at the same time, and the network traffic that is directed to all the computers on a network can be segmented to transmit only on the specific VLAN, because we can define only a specific VLAN to receive the data, etc. And it also improves bandwidth on the VLAN because each VLAN filter the network to network broadcast traffic as well as the collision traffic from other VLANs. Then comes the physical layer broadcast. The physical layer broadcast implemented by non-switched Ethernet network through shared cabling and hubs. In this, each bit that is transmitted is physically received by every station, and switches and VLAN does not do any physical layer broadcast. Then come the MAC layer broadcast. MAC layer broadcast deal with how to handle the MAC level broadcast frame, that is data frame that have the broadcast MAC addresses, and the MAC level broadcast frame are addressed to all the MAC addresses on a given network, and a regular switch forward all the broadcast frames out of all the ports, but a VLAN switch forward broadcast frame only to the ports that are on a same VLAN, and multiple switches can be a part of the same VLAN. And the VLAN switches, as we already discussed, it is the virtual local area network switches. And at the last, I love to share that we have discussed networking, LAN failures, cable connectivity, hub bridges, switches, and how to manage the network services over the TCP/IP. That's all about. Thank you.